All right, let's look at number 12. It wants the mass of 5.33 liters of dinitrogen trioxide. So if you remember, when we looked at our moles, I'm going to put this over here real quick. Our moles is kind of our central unit here. And if we know moles, we can get to liters or volume. We can get to particles or molecules or atoms. And we can also get to mass in grams. So we can go there, up, over, but moles is always kind of our central unit here. So let me go back to our question here. This guy, I've got liters, 5.33 liters of dinitrogen, so N2 trioxide O3. Now I want to get to mass down here. So I got to go from liters to moles and then moles to grams. Remember, there's always 22.4 liters for every 1 mole. So I'm going to start with my 5.33 liters, and I'm going to do 22.4 liters down here for 1 mole of my N2O3. That gets me to moles. Now I got to go to grams. And remember, in order to get from moles to grams, you have to use this is the molar mass. By looking at the periodic table, I need to add up 2 N's and 3 O's. So since I crossed out liters going diagonally to get to 1 mole, I have to have my 1 mole down here. And this number came from 2 N's and 3 O's from the periodic table. So now we just multiply across and divide going down, and we should get 18.1 grams of N2O3. Let's look at number 15. 15. How many grams of NaBr do I need to make 120 milliliters of a 2.50 molar solution? So whenever we see this molar, that means concentration. And remember, molarity, concentration, is moles divided by liters. So I'm given 2.5 molar solution, and I'm given 120 milliliters, which we need it in liters. So I'm going to say that that's 0.120 liters of solution. Now, by knowing these two, I can multiply these two together to get moles of solution, right? Because molarity is moles divided by liters. I know liters and I know the concentration. So multiply these two together to get moles. My question wants grams, but if I multiply these two together to get moles of NaBr, I know that I can get to grams just by the molar mass of NaBr. So 1 mole on the bottom to cancel out. And then I added 1 Na and 1 Br to get that molar mass. So then we multiply across, and that will cross off moles and give me grams of NaBr. All right, 21. Let's find 21 here. Oh, here we go. 21 is looking at, I need to make 10 liters, so that's a volume. And when it says I need to, that means I don't have it right now. So I need to get a volume 2 of 10 liters. And that concentration that I need to find is a molarity. M2 is 1.2 M. What molarity would the potassium nitrate solution need to be? So it's asking M1 question mark. I don't know what that concentration needs to be. If you were to use only 2.5 liters of it. So my volume that I'm using of it is 2.5 liters. So then we just use the dilution, because we're diluting here. M1 V1 equals M2 V2. And so I would set it up M1 times V1 equals M2 times V2. And then to get M1 by itself, I need to divide both sides by 2.5 to get that concentration that it needs to be. And then 22 Let's look at this guy. Determine the mass of calcium nitrate in each milliliter of a solution prepared by diluting. Okay, so I see the word diluting and I'm thinking M1V1 equals M2V2. I'm given 56 milliliters, that's a volume, of this concentration. So concentration is 0.750, and a final volume, so V2, of 0.1 liters. So I need to find M2, which I can do. The only thing I need to look at here is I have different units. This is liters and this is milliliters. So I'm just going to make this 0.1 liters, times it by 3. So 100 milliliters. Okay, so I just want we could have taken this and put it into liters. It wouldn't matter. So I'm going to do M1V1 equals M2V2 to solve for M2, which I did right here. Now, when I get that unit, M2, which we got is 0.3948, that's my M2. Remember that this stands for moles per liter, 0.3948 moles per liter. That's what capital M stands for. I did moles divided by liters to get that. My question wants grams per milliliter. If I have moles per liter, I can simply get rid of liters by putting it up here. And I want mLs on the bottom, right? Get rid of liters. I want grams per milliliter. So we want milliliters on the bottom. So we know in 1 liter, there's 1,000 milliliters. All right. So right now, if I were to leave it, I would have moles per milliliter. I don't want moles per milliliter, though. I want grams per milliliter. So how do I get rid of moles? I would need moles on the bottom because I have moles on top here. And I need grams on top. And we know that for every 1 mole, we can look at the molar mass of, what is it? Calcium nitrate. So calcium is a +2 because it's in my second column. And then I would look at my polyatomic ion sheet and see that NO3 is a -1. So this compound would be 1 calcium and 2 nitrates. So when I find this molar mass, like I did over here, I need to add up 1 calcium, 2 nitrogens, and 6 oxygens. And I found that molar mass to be 164.088 grams per mole. So that would go right here, 164.088 grams. So when you're looking at my answer key here, I took that 0.3948 molarity, which is moles per liter. I put my liters on top. Doesn't matter if these two are flipped around. Liters to get rid of the liters. And then my moles need to go on the bottom to get rid of moles with the molar mass. All right, hopefully that helps.